I really like this question on inverse trig values. It's just like I've never seen anything quite like it before. Um, and so that's what this paper is kind of about, being able to look at these slightly unseen situations and deal with them. Now I'm going to go through this in two different methods. The way that the mark scheme goes through it, first of all, because to be fair, it's quicker. And then secondly, a much longer way that I went through, but I quite like it, so I'm going to do both. The first thing to note really is that we're going to expect to get a nice answer, okay? So, like it's you kind of know if you've gone wrong because you won't be able to get like a pi out of there or a multiple of pi. So, first thing to say is to like look at the values and think like, do we know what any of these are? And in fact, this one here, you should know that it's going to be pi. So I always remember that cos 30 is root 3 over 2. Cos 45 is 1 over root 2. I'm just talking through my process of remembering it. And then cos 60 is equal to a half. It's going down in value over time. And cos 45, well, that's the same in radians as pi over 4. So in fact, we're working in radians here. This one here is going to be pi over 4. We don't need to worry too much about that. It's just the remaining two. So this is what the mark scheme does. It says, right, we're just going to focus on each one at a time. So inverse sine of a third, let's call it something. Let's call it A, for example. This implies that um, sine A is equal to 1/3. And we can draw a little triangle to see what's going on. So if I call this angle A, then I've got the opposite over the hypotenuse is 1/3. Um, and there's not a great deal I can do with that at the moment. I can't find out what A is, but at least we've got it written down. Now we'll go with arc tan. So I've got actually, I'll call it, I'll stick with 2 in this tan, 1 over root 2, and I'm going to call that one B. And that will mean that we'll have to divide by 2 and then find tan of it. So it's going to be that tan of B over 2 is equal to 1 over root 2. And I'm going to draw another triangle, this time with B. But actually, sorry, it's B over 2. So let me draw that a little bit bigger. And then I've got the opposite over the adjacent is root 2. Um, it's perhaps good at this point, like there doesn't seem to be a connection, but let's find out some of like the other sides. So this side would be 3 squared minus 1 square rooted. It's going to be root 8. And this one over here is going to be root 3. So we've got tan of b over 2. What we actually really want is tan of b. Um, again, it's not kind of obvious why you want to do this necessarily, but just playing around with it. And at the moment, we can't get a and we can't get b over 2, but maybe b will give us some insight if we can get tan of b. So there's a double angle formula. Tan 2a is equivalent to 2 tan a over 1 minus tan squared a. And this means that tan a, I can use half angle formula. I can replace 2a by a. Tan a is going to be 2 tan a over 2 over 1 minus tan squared a over 2. And therefore, tan b is going to be 2 times 1 over root 2. That's my tan b over 2 over 1 minus 1 over root 2 squared, which is just be a half. And that's going to be, well, this bit up here is just root 2. and I'm dividing by a half, so I'm going to get 2 root 2. And that is actually, it's more important than you think, because that is none other than root 8. They're the same thing. So if we look at this again, we've got tan b is 2 root 2, or 2 root 2 over 1, and that means it can go up here, because tan b here is root 8 divided by 1, or 2 root 2 over 1. So absolutely crucial aspect of this question is to recognize that. And then we are sorted, because we don't know what A and B are, but they must add to 90 degrees, or in radians pi over 2. So I'm just going to write down put in triangle above. So A plus B equals pi over 2. And hence, it was inverse cos of 1 over root 2 plus inverse sine of a third plus 2 inverse sine, inverse tan of 1 over root 2 will equal pi over 4 from that inverse cos of 1 over root 2 plus pi over 2, which is going to be 3 pi over 4. And that's our answer. Um, Fair play if you did it that way. Like I know that, I just went along a different lines that I'm going to show you. Um, I can see why you draw the triangle. It's like suddenly, recognizing to then find tan B and seeing the link to that I think is pretty tough in this question. But understanding it, on the other hand, is easier than what I'm about to show you. Right, method 2 for this question. This gets pretty epic, but I don't know. I kind of prefer it, if I'm honest. Right, we're trying to find this value. Now, what I chose to do is actually find tan of the value. And by the way, I know that this is pi over 4, so I'm just going to write that in straight away. And the reason I did this is that I thought, okay, I can now use addition formulae to try and separate it out. And in the case of this one over here, I can do tan of inverse tan and so on. And of course, cos and sine are more difficult to deal with, but there are ways, because tan is to sine over cos. So I can use lots of kind of knowledge that I have. Would this work for sine and cos? I think it should. I think finding cos of inverse tan is like a bit trickier though, but it should work. But I've gone with tan. So this is my next line. I can write tan pi over 4 plus inverse sine of 1/3. And then what I did is I split this up into inverse tan 1 over root 2 plus inverse tan 1 over root 2. So I've got 4 things. Now I'm going to treat this bit as capital A and this bit as capital B, because then I can use tan A plus B is tan A plus tan B all over 1 minus tan A tan B. Let me call this thing star. So star equals, and therefore star is going to equal tan of pi over 4 plus inverse sine a third plus tan. I'm not going to have enough room, am I? Of inverse tan 1 over root 2 plus inverse tan of 1 over root 2 all over 1 minus tan of this. By the way, let me just say where we're trying to head to. I know my answer is in terms of pi. So I'm expecting to get tan of um, something nice. Like we know that tan, um, so we know that tan of pi over 4 is equal to 1, for example. So I'm expecting to get whatever I have here equal to, say, 1 or root 3 or 1 over root 3 or something like that, because then I can get back to what the actual thing inside the bracket is. I hope that makes sense. Right, again, I've like not left enough room here. Sorry. Just going to write this out again. I started chatting and haven't. This is quite a long line. This is going to be 1 minus tan A times tan B. Okay, next up, I'm going to sort these out. So actually, there's just two really that I need to focus on. I'm not going to do it all. I'm just going to like separate it now. So this one here, let's work out that. Well, I've got, I could use addition formulae for tan again, but I'm going to be finding tan of inverse sine. Would that work? Um, yeah, I'm going to go down the path that I did it. So I changed it to sine over cos. And then I applied addition formulae for sine. So you get sine, and now this is my A and this is my B. So I get sine A cos B plus sine B cos A all over. And now this is my A and this is my B. For cos addition formulae, I get cos pi over 4 cos inverse sine 1 over 3 minus sine pi over 4 sine of inverse sine 1/3. And you might think looks horrendous, but it is going to simplify. Sine of pi over 4 is 1 over root 2. This thing here, well, cos is actually equal to 1 minus sine squared. And so this, I'm going to do the first one slowly, but cos of inverse sine 1/3. Sorry, yeah, and so cos squared is 1 minus sine squared, so cos is the square root of 1 minus sine squared. Apologies. So cos of inverse sine 1/3 is going to be the square root of 1 minus sine squared inverse sine of 1/3. And basically we find sine of inverse sine, which is 1/3, and then we square it. So we'd get 1 over 9. So we would get root 8 over 9. Okay, I've done that one in some detail. I'm actually just going to put it in. I'm just going to replace this by root 8 over 9, or equivalently root 8 over 3, if I take the square root of 9, plus 1/3 times 1 over root 2, then all over 1 over root 2, and then similar thing again here. We're going to get root 8 over 3. But this time it's minus 1 over root 2 times 1 over 3. Now, I could have done this earlier actually. If I'd recognized that sine pi over 4 has the same value of cos pi over 4, I could have just cancelled them all out. I can in fact just do that now. If I divide top and bottom by 1 over root 2, then I divide each term by 1 over root 2, and I can also multiply top and bottom by 3, which means this goes and this goes, and suddenly it's looking a lot nicer. All right, remember that is this that's this thing here. Okay, I've worked out this and this. Okay, so in a minute I can replace them, but I've still got to work out tan of inverse tan 1 over root 2 plus inverse tan 1 over root 2, but that will actually be a lot nicer. It is maybe it's possible that I could have taken more shortcuts in this question. This is just what my brain was thinking when I did it. Um, so I'm going to get tan A, which is just 1 over root 2, plus tan B, all over 1 minus tan A times tan B, which is going to give me a half. Now this will be 2 over root 2, which is just root 2, and I'm dividing by a half, so I'm going to get 2 root 2 as my answer. Arguably, I could have written that as 2 inverse tan 1 over root 2 and then used the double angle formula. Anyway, look, this is how I did it. Okay, so therefore, star is going to equal, remember, star is tan of what I actually want. So now, where am I? Oh yeah, it was here. I said I could replace this by root 8 plus 1 over root 8 minus 1. And then I can replace this and this by 2 root 2. And it's all over 1 minus root 8 plus 1 over root 8 minus 1 times 2 root 2. Okay, agreed. This doesn't look very nice at the moment, but it's gonna, trust me, it's gonna simplify. So what I did now is I rationalized the denominator on this surd. So it's going to be root 8 plus 1 all squared. I'm timesing top and bottom by root 8 plus 1. When I do that on the bottom, I'm going to get 8 minus 1. And then I'm going to leave this as it is. So they're the same thing by just timesing through by root 8 plus 1, top and bottom. All over 1 minus, same thing. Right, now what I can do is note that this is 7, so I can basically times through by 7, top and bottom. So it's going to disappear from here and be left with this. I have to times this term by 7 and times the 1 by 7. I forgot to put the squared there, sorry. Now expand the bracket. 8 plus 2 root 8 plus 1 plus 14 root 2. all over 7 minus 8 plus 2 root 8 plus 1 times 2 root 2. This is going to equal 9. Now, root 8 is equal to 2 root 2. So this is going to be 4 root 2. So I'm going to have 18 root 2. And then I'm tempted, I think, oh, what should I do? Okay, what shall I do here? Okay, I'm just going to take it a little bit more slowly. So I'm going to get 9 plus, this is going to be 4 root 2 times 2 root 2. You kind of got to believe yourself that this is going to, we're nearly there. We're going to get something that makes sense out of it. So it's going to be 7 minus 18 root 2. And then I'm going to minus 4 times 2 times root 2 times root 2. That's going to be 8 times 2. That's going to be 16. I'm going to be minusing 16. Which gives me, I'm going to get minus 9 minus 18 root 2, which is the same as minus 9 plus 18 root 2, which just gives us minus 1 as our answer. Now, this is not the final answer, because therefore, and this is right back to the beginning, remember that is tan of the answer. So inverse cos 1 over root 2 plus inverse sine of 1/3 plus 2 inverse tan of 1 over root 2 will equal inverse tan of minus 1. Except you've got to remember that, like, we're actually solving an equation, so you need to find possible different values. So one value is going to be minus pi over 4 because it's here on the tan graph, but there's more because the next one will be here and we have to add pi to it. So that would give us 3 pi over 4 and so on. Now we can ignore this one because each of these values will be positive. And we can also do a little bit of thinking. We know that we get pi over 4 from this one. Now this one is going to be less than inverse sine of a half. So it's going to be less than pi over 6. It's not going to be like massive is what I'm trying to say. And then this is also not going to be that big. So it's not like it's going to be the next one on. And so I feel like we are justified. I don't know if that's a bit hand wavy at the end, but we are justified in saying that that is the answer. So to summarize, two very different methods for solving this problem. This was pretty epic. This was much simpler, but quite subtle. I think this is a tough question. Like I remember when I first looked at it, I was like, I don't even know how to begin. I do see now that I've seen it this way. I think I'd do it this way next time. Because it's only because it's kind of like a very particular set of values that work, but I suppose otherwise you wouldn't be asked it in a non-calculator setting. This is worth bearing in mind now, I think, my other method. Okay, I quite like it. I like the fact I came up with it. And we do still get to the answer. So good question anyway.